Circuit with resistance and capacitance in series. Here we can see that this is a AC circuit containing resistance and capacitance in series. Let VR is the voltage drop across this resistor R and VC is the voltage drop across this capacitor C, and this current I is the current flowing through this circuit. This is a AC supply and this V is the applied voltage. Now VR is equal to I into R. According to Ohm's law, voltage is equal to current into resistance. Also, VC is equal to I into XC, where this XC is the capacitive reactance. Also, this XC is equal to 1 by omega C. This omega is the angular frequency. This is a phasor diagram. This is a current as a reference. Now this VR is the voltage drop across resistance R. So VR and I are in phase. This is a VC, voltage drop across capacitor C. So this VC is lagging this current I. This V is the resultant voltage. This is a phi in clockwise direction. Now from this phasor diagram we can draw voltage triangle. So this will be equal to this will be equal to this value. So here this will be VC. This line will be VC. Remaining as it is, this is V. So V is equal to IZ. This will be VC. VC is equal to I into XC. And this is VR. So VR as it is, VR is equal to I into R. Now this is a right angle triangle. So this will be hypotenuse. This will be opposite side of this angle phi. And this will be adjacent side to this angle phi. Now XC will be taken as negative since the direction of this XC is in this downward direction to this axis Y. So this will be taken as negative. This is a waveform. As we can see that this current I is leading and this voltage is lagging. Now if we apply Pythagoras theorem to this voltage triangle, then V square is equal to VR square plus VC square. Hypotenuse square is equal to adjacent side square plus opposite side square. So here this will be V square is equal to VR square plus VC square. From this V is equal to under root of VR square plus VC square. Now if we take the values of this, so this will be I into R. VR is equal to I into R and VC is equal to I into XC. From this we can take I square common. So V is equal to under root of I square in bracket R square plus XC square. Now we can take this I square outside of this under root. So this will be V is equal to I into under root of R square plus XC square. Now from this the value of I will be I is equal to V by under root of R square plus XC square. Now this will be impedance Z. So I is equal to V by Z, where Z is equal to under root of R square plus XC square. This Z is the impedance. Its unit is ohm. This R is the resistance and this XC is the capacitive reactance. Now this is the impedance triangle. Impedance triangle is obtained by dividing each side of the voltage triangle by I. So here in this voltage triangle, if we divide this by I, so this will be R. If we divide this by I, so this will be XC. And if we divide this by I, so this will be Z. So we have to divide all the side by I. So we get R, XC and Z. So this will be our impedance triangle. So this is a impedance triangle R, XC and Z. Now tan phi is equal to opposite side upon adjacent side. So this will be opposite side is minus VC. Here we can see that opposite side is this minus VC. This minus VC. So this Vc is in the downward direction. So this will be taken as minus. So this will be minus. The direction of angle phi is clockwise. Also we can say that the direction of this phi is clockwise direction, like this. So that's why this Vc is taken as minus. So minus Vc by Vr. Adjacent side is Vr. Now Vc is equal to I into Xc. So minus I into Xc divided by Vr is equal to I into R. This I and this I will get cancelled. So tan phi is equal to minus Xc by R. Tan phi is equal to minus Xc by R. This Xc is the capacitive reactance. Now cos phi is equal to adjacent side upon hypotenuse. So adjacent side is here we can see that adjacent side is Vr. Divided by hypotenuse. Hypotenuse is applied voltage V. So Vr is equal to I into R and V is equal to I into Z. This I and this I will get cancelled. So cos phi is equal to R by Z. Cos phi is equal to R by Z. Now from this also we can say that Vr is equal to V into cos phi. This Vr, voltage drop across resistor R, Vr is equal to V into cos phi. Voltage and current in circuit can be represented by V is equal to Vm sin omega t, I is equal to Im sin omega t plus phi. In case of inductive circuit, we have seen that this is negative. But in case of capacitive circuit, this will be positive. This phi is the phase angle between applied voltage and current. Power is equal to average power taken by resistance plus average power taken by capacitance. But average power taken by pure capacitance over a complete cycle is 0. So power is equal to only average power taken by resistance. P is equal to I square R. Now if we separate this, so this will be P is equal to IR into I. So P is equal to VR. We can replace this IR by VR. VR into I. Now this VR can be replaced by V into cos phi. So V into cos phi into I. So this will be power is equal to VI cos phi watts. The unit of power is watt. Cos phi is power factor of circuit.